All right, our Chapter 6 review. The first thing we want to do is talk about simulations. Now, if I'm going to have a simulation, maybe I'll make a problem. Say um, a baseball player that's 300. So the average is 300. That means 3 out of every 10 times he comes up to bat, he gets a hit, excluding some other things, but let's just use it as its base level. So the first thing we want to do, state this, talk about the assumptions. If we're going to do this many times, we want to assume that um, each bat is independent. Then we want to assign digits to represent the outcomes. So if it happens 3% of the time, we can say numbers 1 through 3 represents he gets a hit, while numbers 4 through 10 represent he gets out. Now, we want to simulate this many repetitions. So maybe we want to find the probability he gets hits the ball 8 out of 10 times. That would be a proportion. And the probability gets hit 8 out of 10 times. So we simulate this many times. So we do random integers 1 through 10, and we simulate 10 different numbers. And we see how many times out of those 10 that he got above 8 hits. And over here would be 8 and below. And then you have some kind of tally. And if you got 1 out of 11, you'd say the probability he gets above 0.8 is 1 out of 11 times. Now, we use probability models to talk about a set of data so we can guess what's going to happen in the future. A sample space is all of the possible outcomes. An event is of an outcome is or a set of outcomes of a random phenomena. So it's just what happens. So if I say the probability that you get above 8 out of 10, 8 out of 10 is an event. A probability model is just a mathematical description of that random phenomena. So you have a sample space and you have a way of assigning probabilities to each of the events. So the rules in probability, each probability has to be between 0 and 1. The probability of the entire sample space is 1. And if these are disjoint events, so there's nothing in common in the two events, you can just add them together. If you want to find the probability that something doesn't happen, we call that the complement. The probability that something doesn't happen is 1 minus the probability that it actually happens. And we can multiply two different probabilities to get the probability they both happen only if those two events are independent. So there's sampling with replacement and sampling without replacement. So if we're sampling without replacement, that means we take a card from a deck and then we keep taking it and keep taking it, and we're not putting it back in the deck. So this one, the probability will change. Now when we're sampling with replacement, the probability is going to stay the same. Because we keep replacing what we took out back in and maybe shuffling the cards, so the probability doesn't change as we take more and more cards out of a deck. Now there's different words called of union, intersect, complement, and mutually exclusive, or disjoint. Those two things mean the same thing. A union, it's represented with A union B. That's everything inside both of the circles. An intersection is the things that are in between. They're in common in both A and in B. And a complement is everything outside of that particular circle. Mutually exclusive means that there's nothing in common. So there's nothing overlapping. So here's a question. Find the probability, or the probability the Vikings win a game is 55%. The probability Timberwolves win a game is on the same day is 25%. What is the probability that the Vikings win and the Timberwolves lose? So if I have my Vikings over here, I have my Timberwolves over here, the probability that they both win is 0.55 times 0.25. I could have probably chosen some numbers that multiply together easier, but that's what I'm dealing with, I guess. Uh, and now if I take 55% minus that, I'll know that the probability that just the Vikings win is 0.4125. The probability that just the Timberwolves win is 0.1125. And now if I add up these three numbers, I get 0.6625. So if I take 1 minus that, on the outside, the probability that both teams lose is going to be 0.3375. Now, I went through all of these things, and you don't really have to do all of it, but it's kind of nice to. So if they ask multiple questions, what's the probability the Vikings win? So the Vikings win, and the Timberwolves lose? Well, that's that one. It's probably that the Vikings win, and the Timberwolves lose. So the Timberwolves don't win. That's 0.4125. Now, a certain AIDS test is given to 200 women in a village hospital, and if the probability is 0.04 of getting a false positive, what's the probability that at least one of the women had a false positive? So it's given to 200 women. The probability that, so this, we could set up a probability distribution. The probability that 0 women get a false positive is going to be, it's kind of like a binomial situation, and this is actually a binomial situation, but 0.996 to the 200th power is the probability that no women get this. So if I take 0.996 to the 200th power, that's 44.4486, so say 45%. So the probability that at least one woman walks away thinking she has AIDS when she really doesn't is 0.55, which is a pretty big number, assuming and starting with a very small number of 0.004. So it's not, doctors really don't want this to happen, and especially neither do patients. What is the difference between independent and disjoint events? These are in fairly two words that people confuse a lot. Independent, struggling to spell it, and look, it's just up there. Disjoint, have a hard time spelling and talking, I guess. Disjoint are two things that have nothing in common. There's nothing that is in both data sets. Where independent, if it's independent, it has to have something in common, because for things to be independent, the probability of A times the probability of B has to equal the probability of A intersection B. And so when we're doing this, unless one of the probabilities is 0, and if that's the case, they would be disjoint, and there'd be nothing in that data set. But if there's something in the data set, we multiply these two to get the middle. Bell just keeps going, doesn't it? All right, here we go. Deb and Matt are looking for a promotion at a law firm. Deb thinks that she has a chance of 0.7 chance of getting a promotion. Matt has a 0.5 chance of getting the same promotion. She also estimates the probability they both get the promotion to be 0.3. What's the probability that neither of them get the promotion? So first thing you do is you draw a nice little Venn diagram of this situation where you have Matt and you have Deb. The probability they both get it is 0.3. If Matt has a 0.5 chance of getting it, that means he has a 0.2 over there. And Deb is up here and she has a 0.7 chance, so that's a 0.4 there. Now if we add these all up, we get a probability of 0.9 So if we subtract that from 1, we'll get 0.1 on the outside. So the probability that Deb doesn't and Matt doesn't get the promotion is 0.1. Conditional probability. The probability A given B means the probability that A has occurred, or A happens given that we know B has occurred. We should probably do one. I don't have an example, but we can make one up. Um, so the probability that A occurs is, say, 0.7. The probability that B occurs is 0.6. The probability that they both occur, let's say, is 0.5. There's a couple ways we can do this. There's an equation. The equation says probability of A given B is the probability of their intersection all over the probability of what's given. All right. So now, once we have this, the probability of both of them is 0.5 over the probability of just B, which is 0.6. So that's A given B at a 5/6 chance, whatever that is, 80 something, 83% or something. That's the 83.83 repeating is the probability that that occurs. Now, if you don't remember that formula, even though that formula is given to you on the AP exam, but if you forget to use it, you can draw it out as a Venn diagram where the middle is 0.5. This is B, where it adds up to 0.6. This is 0.2 because it adds up to 0.7. Now, out of what this is saying is out of all of B. So if we're just looking at B, so that's out of 0.6 total, what's the probability that's in A? And that's this section right here, which is 0.5. And, you know, the work is, of course, the same. Well, hopefully that makes sense. And hopefully this helps you understand Chapter 6 a little bit better.